Hello class, today we'll be starting Chapter 10, Thinking and Language. Humans are a pretty awesome species. As a civilization, we have invented the wheel, kept historical records to guide present and future generations, landed spaceships on the moon, and unlocked the atom, cracked the genetic code, and revolutionized the face of all we do with computers that brings us into the global internet. When you stop to think about it, our list of triumphs is long and very impressive. Yet at the same time, we massacre each other in war, wreak havoc on our environment, discriminate against racial and ethnic groups different from our own, and deceive ourselves into believing in alien abductions for all things. This unit will be exploring what it is all about, this unit we will be exploring what it is about the way humans think that lead us to be both rational and irrational. This exploration will encompass how we solve difficult problems, evaluate possible solutions, decision-making processes, and the errors that we are predisposed to make along the way. We will also be discussing the role that language plays in the way we think. What is language, and is it the capacity that most clearly separates humans from other animal species? Over the course of the next few days, we will analyze some of the basic processes of thought and language, then address the question of how they are related. But first, let's categorize thinking within the study of psychology before we begin. Thinking. Thinking is the mental activity involved in understanding, processing, and communicating information. With that information, in what perspective of psychology would you categorize thinking? Thinking is a branch of cognitive psychology, as it is one of the many mental processes such as memory, communication, and knowing. Now let's move on to our analysis of human thinking by beginning our discussion about concepts, which are the basic building blocks of abstract thought and language. Freedom, sports, animals, education, furniture, war, peace, music, heroes, triangles, and happiness. Each of these words represents a distinct concept, a mental grouping of similar objects, events, ideas, or people. As we saw in the last chapter, our long-term storage of knowledge can be pictured as a complex but orderly network of semantic concepts. So when one concept in the network is activated, other closely related concepts come to mind, or are primed. Remember priming from last unit on memory? Some concepts are more closely related than others. We know that it takes longer to reveal connections between concepts that are distant than between those that are closely related. For example, the concept of animal can be differentiated between mammals, reptiles, amphibians, and then mammals we can conceptualize as dogs, horses, monkeys, dolphins. Secondly, some members of a category are perceived to be more typical of that category than others. When people are asked to list properties of different concepts, the most typical member, called prototypes, have more of these properties than others. So, for example, a prototype is the best representation of a concept. All right. So, on that stance, maybe your best mental representation of a dog, what you think of when you think of a dog, is a golden retriever. So, the first time you see a black lab, you compare it to your prototype, the golden retriever. You realize that the black lab looks very similar to your prototype, the golden retriever, so you categorize the black lab as a dog. Because, after all, the golden retriever is the prototype you have for dog. So now that we have discussed the basics of formulating thoughts, let's discuss how we utilize thinking to solve problems. We utilize our thinking and our mental processing for many things. Okay, what we're going to be focusing on in this chapter is more problem solving and decision making. Problem solving is not just applicable to an AP exam. We use problem solving to determine many things. Once a problem is represented, whether it's through words, static images, or mental models, we try out possible solutions and test to see if they work. If the problem is solved, life goes on. If not, we return to the proverbial drawing board to come up with the new ideas. There are many different ways to find solutions, but there are 4 basic problem-solving processes. trial and error, algorithms, heuristics, and insight. But first we're going to focus on trial and error. With trial and error, as you can imagine, this aimless hit-or-miss approach is not the most efficient way to proceed. Yes, it is usually our first response, but if possible, however, it's better to take a more systematic, planned approach. All right, but the problem-solving approach, first, you must identify the problem. So, for example, let's say your car won't start. And then you need to gather information. Are you out of gas? Is the battery possibly dead? And then you try possible solutions. If you're out of gas and you fill up the gas tank and the car still doesn't start, then it's something else. Okay, maybe because of all the weather we've been having lately, too much condensation is built up on the cables connecting your battery. So what do? You dry off your cables, and voila, the car starts. Trial and error has been successful. All right, and if the car doesn't start, then well, you just try a different solution. Okay, but back to what I said earlier. It's better to take more systematic approaches. So let's talk about two other problem-solving strategies. The next two problem-solving strategies are algorithms and heuristics. An algorithm is a step-by-step procedure that is guaranteed, eventually, to produce a solution. When you were taught in school how to solve two-digit addition problems or long division, you learned an algorithm. An alternative to the algorithm is the use of heuristics. These are mental shortcuts or rules of thumb which may or may not lead to the correct solution. The I before E heuristic for spelling IE words is a good example. To appreciate the difference between algorithms and heuristics, consider the following anagram problem. Unscramble the letters on the next slide. Now, if you're having trouble unscrambling these letters, you might want to consider all 900,000 combinations of these letters. If that's your problem-solving strategy, then you're using algorithms. Now, if you throw out abnormalities to the English language, such as the two Y's going back to back, then you're gonna make your problem-solving strategy more efficient. It's going to be less time-consuming, but you could be prone to error. Have you figured out the unscrambled word yet? It's psychology! So heuristics. Here's a good simulation of heuristics. All right. Who would you trust to babysit your child? The woman below or the man above? Well, the old woman below looks very nurturing. She looks very calm and peaceful and appears to pose no threat to you or your child. Whereas the man above, it's the opposite. He does pose a potential threat, or at least he looks like he does. He looks like he wouldn't set a very good example for your child either. I mean, do you want your child looking like that? Probably not. So most people, probably 9 out of 10, if not 10 out of 10, would pick the little old lady to babysit their child. This answer is based on your heuristic of their appearance. Okay. We associate the old lady with a more nurturing personality, whereas above we associate this man with a more violent and threatening personality and behavior. Okay. Remember, heuristics is a shortcut that can be prone to errors. It narrows your problem-solving space, and it's less time-consuming, but it often leads to errors. So, for example, maybe the little old lady is carrying a gun in her purse. Maybe she's a 3-time convicted felon for assault on a minor. Would you want her babysitting your child? And look at the man above. Maybe he's an EMT. Maybe he's a certified nurse or certified in CPR and first aid. And it's his life work. It's his life's passion to work with youth and young children. But you didn't look into that. You didn't do a background check on any of these people. You just made a shortcut. You relied on rule of thumb based on their appearance. Again, that's a heuristic. Now, there are multiple types of heuristics. There are 2 types that we're going to focus on: availability and representativeness. So first, let's start on availability heuristics. An availability heuristic states that we estimate the likelihood of an event based on their availability in our memory. So if it comes to mind easily, or as a vivid event, means a meaningful event, we presume it to be more common. So for example, although diseases kill many more people than accidents, it has been known, or it has been shown, that people will judge accidents and diseases to be equally fatal. This is because accidents are more dramatic and are often written up in the paper or seen on the news on TV, and are more available in the memory than disease. Let's say you're planning a family vacation, and you can't decide whether to drive or to fly. But you've noticed on the news lately that there have been a lot of plane crashes, so you and your family opt to drive. If you had done some research, you would know that driving is significantly more dangerous than flying. But because you used your availability heuristic, you opted to drive instead of fly instead. So let's move on to our next heuristic, representativeness heuristic. Representativeness heuristic is a rule of thumb for judging the likelihood of things in terms of how well they match our prototype. This is similar to the babysitting example, and it can cause us to ignore important information. So for example, look below. This is Linda. She loves books and hates loud noises. Is Linda a librarian or a beautician? Most people would say, based on the facts given, most people would say that she's a librarian because someone who loves quiet and loves to read typically fits a prototype of a librarian. However, if you were to look into statistics and use algorithms, you would know that there statistically are many, many more beauticians in the world than there are librarians. So statistically, it's much more likely that Linda is a beautician. Our next and final problem-solving strategy is insight. Insight is a sudden realization of the solution to a problem. It is not strategy-based, and the answer just comes to you out of nowhere. All right? Have you ever been thinking about a problem and then the solution just pops into your brain? You don't use trial and error, you don't use algorithms, you don't use heuristics. It just pops into your brain. Well, that's insight. The psychological researcher who studied insight is his name is Wolfgang Kohler. And for his experiments, what he would do is he would hang a banana from a ceiling and fill that room with boxes and see if the chimpanzee could figure out how to get to the banana. Well, oftentimes the chimpanzee would just look at the boxes and then suddenly realize if he stacked the boxes, he could reach the banana. That was a moment of insight. Another experiment placed a monkey in a cage and put a 2-foot-tall graduated cylinder in front of the monkey. The researchers then put a peanut inside the cylinder. Well, of course, the monkey couldn't reach the peanut. So how is the monkey going to be able to eat? The monkey sat there and stared at the graduated cylinder for quite some time, and then all of a sudden, the monkey had an insightful moment. The monkey, the chimpanzee, took a lot of water into his mouth from his water bowl and then filled the tube, the graduated cylinder, with the water, eventually so that the peanuts would reach the top and the monkey could eat it. That was, again, a moment of insight. Can you think of any instances where you experienced insight?